Okay, so now we'll look at this problem. Consider state of population 3 million and that 60% of this population is initially susceptible to a disease. The rest of the population are immune to the disease. Determine the basic reproduction number for the disease, which could be anywhere from 1 to 5. Alright, so you're given the population that will not be infected with the disease, which is what? 60% of the population is initially susceptible to a disease. So that is S0, 3 million times 60%. Okay, so 60% times 3 million is 1.8 million, that is S0. And the rest of the population is not going to be susceptible, that is, they're immune to the disease. That is 40% of 3 million. So 40% of 3 million is 1.2 million. And remember the equation we had before for I max. So I max is n minus this term. So that is the minimum number of people who are not going to be infected at any time, and that is what is given here as 1.2 million. So 1 over q times 1 plus ln of r number r hash is 1.2 million, where r hash is our basic reproduction number and q is going to be c over r. Now q is related to r hash as 0 with this relationship here. So q is c over r, and now we have r hash as c times s0 over r, and c over r is q, so q is times s0 is r hash. So q is basically r hash over s0, and so that's what I'm using here. So q is r hash over s0. So 1 over q, if q is r hash divided by s0, 1 over q is s0 divided by r hash, which is 1.8 million divided by r hash. So 1 over q, so in this expression you have it as 1 over q, so that's why I found here 1 over q. So replace 1 over q by 1.8 million divided by r hash times 1 plus log of r hash, and it's equal to 1.2 million. So here we have to find this r hash as the parameter whose value is not available. So simplify this, 1 plus log of r hash divided by r hash is 1.2 million divided by 1.8 million, which is 0.67. So we have to basically solve this equation for r hash, and you could use any approach that you can solve. I'm going to use here binary search to find the value of r hash. So again, this is the equation you want to solve for r hash. Now you are also given that the r hash could be anything from 0 to 5. So let us try to apply the extreme values. If r hash is 1, now let me call this as r hash ratio just to keep things simple for discussion. So if r hash is 1, substitute for r hash here to be 1, 1 plus log of 1 divided by 1. So log of 1 is 0. So 1 plus 0 over 1 is 1. So we get a value for this r hash ratio which is greater than 0.67. Now if r hash is 5, r hash ratio is 1 plus log 5 over 5, which comes out to be 0.52, and that is less than 0.67. So this is an ideal case for using binary search, where you can set the left index to be 1, which is the value for r hash, such that r hash ratio comes out to be 1, which is greater than 0.67, and the right index to be 5 for r hash, where r hash ratio comes to be 0.52 and less than 0.67. So the value of r hash for which the r hash ratio is going to be 0.67 is somewhere in between 1 and 5, and that's what we're going to determine using binary search approach. So if left index is 1, right index is 5, middle index is 1 plus 5 over 2, the average of left and right index, which is 3. So substitute r hash equals 3 in this r hash ratio expression and find what value of r hash ratio we get. So 1 plus log 3 divided by 3 comes out to be 0.69, and it is greater than 0.67. So that means you can move the left index to the right by setting the left index to be the value of this middle index. So left index is 3, right index is 5, middle index is now 3 plus 5 over 2, which is 4. So substitute 4 for r hash and find the value. So 1 plus log of 4 divided by 4 comes out to be 0.59, which is less than 0.67. So that means the right index could be moved to the left. Okay, so we set right index to be 4, left index says as 3, and the new middle index is 3.5. The value of r hash ratio at r hash to be 3.5 is 0.64, which is also less than 0.67. So we can move the right index further to the left and set it as a middle index. So 3 for left index as it is, 3.5 now the value for right index. The middle index is now 3.25. Substitute r hash with 3.25, we get 0.67. So we are rounding to 2 decimal places, and that is also equal to 0.67. So the value of r hash we have is 3.25 for the DCs. And one other similar problem, consider a set of population 3 million, and that in this case 90% of this population is initially susceptible to the disease. So S0 is 90% of 3 million, which is 2.7 million. So the rest of the population, which is 10% of 3 million, that is 0.3 million, is immune to the disease. So that's the minimum number of people who will not get the infection. So 1 over q times 1 plus log of r hash is 0.3 million. Now again, q is r hash over S0. So 1 over q is S0 times divided by r hash. So it is 2.7 million divided by r hash. Substitute for 1 over q as 2.7 million divided by r hash. So 2.7 times 1 plus log of r hash divided by r hash is going to be 0.3 million. So 1 plus log of r hash divided by r hash is going to be 0.3 million divided by 2.7 million, and that comes out to be 0.11. So again, we have to solve this equation for r hash such that the r hash ratio is going to be 0.11. So again, we are given that the r hash number could be anywhere from 1 to 50 in this case. So if r hash is 1, we're getting r hash ratio to be 1, which is greater than 0.11. On the other hand, if r hash is 50, r hash ratio comes out to be 1 plus log 50 divided by 50, which is 0.098, which is less than 0.11. So r hash, for which r hash ratio is 0.11, is in between these two extreme values. So use the left index as 1, right index as 50. So the middle index is 50 plus 1 over 2, which is 25.5. So the value of r hash ratio at 25.5 for r hash is 1 plus log 25.5 divided by 25.5, that is 0.16, which is greater than 0.11. So that means we can move the left index to the right by setting it to be 25.5. The right index is 50. The middle index is average of these two, which is 37.75. And substitute now r hash to be this, we get 0.12 for r hash ratio, which is again greater than 0.11. So we can set the left index to be 37.75, right index to be 50, and middle index is 43.875, for which r hash ratio evaluates to 0.1089, which is less than 0.11. So you can move the right index to the left by setting it to be 43.875, and the new middle index is 40.8125, and the r hash ratio for that is 0.1153. So we stop at two levels of decimal precision. So we can say the basic reproduction number is 40.8125. We can stop even here at 2 decimal levels of precision if you want to. So let me take it back, because we'll stop at 2 decimal levels of precision. So I can put it like this. So basically then don't need this. So sorry for this confusion. So this is going to be 43.875. So if you're going to use 2 levels of decimal precision, you can stop at 0.1089, and that is 0.11. two levels of decimal precision. So you have to round it to the nearest possible integer. So next nearest possible decimal value. So okay. So the basic reproduction number is 43.875. So that's the value of the middle index at which we used as r hash value and found the r hash ratio, which came out to be 0.11 when rounded to two decimal places. So we is equal to 0.11. So we set this r hash value to be the final r hash value that we're looking for. Okay, just that the r hash ratio is 0.11. So let's stop with this.